Okay, we're going to take a look at how we might be able to do this problem if we did not assume that that the top triangle was an isosceles triangle. So we've got similar triangles here, A, B, C, if you want to call those A, B, C, and then we've got, I don't know, D and E. And we basically want to figure out how we can divide these up so that we get half, so that both these shapes will give us half the area of the big triangle. So we know that the area of the large triangle is 965, so we know if we divide that by 2, then the areas have to be basically 482.5 each. So how are we going to get this triangle up here to have the dimensions that will give it that area? And we know that the long sides are 53 and 45. So one of the properties, if we could not do this, assume that we had isosceles triangles, we could work with another property, geometric property, which is the area, a ratio of areas of similar triangles. So let's just take a look at the property of similar triangles. So these are two similar triangles, all right? And we've got the ratio of their sides. In this case, this is 7.4, and its corresponding side in the little triangle, LM, is 3.7. And if you divide those, you get a ratio of 2 to 1. Now, if we look at the areas of these triangles, they give us the area of the big triangle as 36.9, and of the little one, 9.2. And what we get when we do the ratios of the areas of these similar triangles is we get 4. Now, let's change this, and let's make this a little bit bigger. Let's make it, if I can, 9. Okay, so now we've got an area that's 83.1 and 9.2 because it hasn't changed. And we've got a side that's 11.1, to its corresponding side is 3.7. So if we look at the areas, and the ratio of the areas comes out to be 9. And the ratio of the sides, corresponding sides in these similar triangles, P, Q, and LM, is 11.1 over 3.7, which is 3. So what's happening is the ratio of the areas is like the square of the ratios of the sides, right? So we take this back down to, well, we can take it back down to 4, if we can. It will let us. So what are we saying? We're saying that the ratios of the areas is the square of the ratio of the sides. So how does that translate into the question that we're dealing with here? So we know what the ratio, we know what the areas, the two areas of the triangles are. The big one's 965 and the little one's 482.5, if we're going to have it half. And what we do is we take corresponding sides. So we can say that this is the big side, all right, 53, and its corresponding side is going to be X. We don't know what it is. So that's that side there. And so when we set up similar triangles, we set up the ratio of the areas, area 1 over area 2. And that's going to be equal to, remember, it's the square of the ratios of the sides. So the square, now you have to keep it consistent, so we say little side, because the top is the little triangle, over the big side, 53. And it's the square of that. And so now what you do to find x is you just solve for x. Make times by 53, both sides, and then square root, and you'll get x. And that is another way that you can divide up shapes and find areas, designated areas. This is just another way that you can do this.